Hello everybody, this is Dr. Ildek, and we have now experiment number 3. It is about resistance, how to read and measure resistance. So the objectives are to know first the color code to find the resistance, and then calculate the tolerance for resistance. Tolerance means, for example, if the resistance is 1 kilo ohm, it is not usually 1 kilo ohm. It is maybe 1 kilo ohm plus a few ohms or minus few ohms. This is what we call it tolerance. Third, we need to measure the actual resistance using the multimeter. So I'm expecting that you have the multimeter already. Then how can we make up some resistors using series and parallel connection? The color code, okay. The resistor has some colors. So for example, if you look at a resistor like this one here, for example, I don't know if okay. So hope that you can see it. Okay. So it has some colors. Every resistor has some colors. You can read it from the colors. Okay. So each color has a number. Like here, this explains everything. So for example, if we have only four colors, sorry. So like this, you have one color, second, third, and you have the fourth color. Each color has a number. So for example, if you look at the first one, first color is red. Red is 2. Red is 2. Second color is green, so green is 5. Third color is orange. Orange is 3. Fourth color is supposed to be, what is this? This is gold. Gold is what? Where's gold? This is gold is here is 5%. So how can we read this resistor? So to read the resistor, simply you just put the numbers. So for example, the first color here is 2. Okay, this is the first color. Red is 2. Second color is 5. This is a green. Third color will be the number of zeros or multiplier. Number of zeros or multiplier. So in this case, we have orange. Orange is 3. Then you have actually 3 zeros. Or you can say this is kilo. 3 zeros means kilo. So it's 25K. This one is 25 kilo ohm. Okay. Plus or minus the fourth color, which is tolerance. So tolerance is this is gold, and the gold is 5%. 5%. Okay, and to know what is the value of this 5%, you need to calculate it. Okay, see here, where is the calculator? It is. You need to calculate it. What's 5%? 5% is 5 over 100. This is 5%. Time 25,000 equal 1250. So this is what? This is the tolerance. This is the error. So this is the expected error. Then in this case, the total resistance is supposed to be 25,000 plus or minus 1250. So this is the range of this resistor or resistance. So you can rewrite it like this, and you can say, okay, this equal. You can say 25,000 minus 1250 equal. So this is a number. Edit, copy. You can paste it here. Paste. Okay, come on, let's write it. So it is 23,750 So this is the minimum value to what? To 25,000 plus 1250. So it will be 26,250. So this is the maximum number. This is the minimum number. So this is a 5% error. That is supposed to be 25,000, but in reality, it is in this range, within this range, from 23,750 to 26,250. If we have a resistor that has, for example, 4 colors, like this one here. So it's the same idea, but we just add a number. Okay. So in this case, the first number is what here is yellow. Yellow is 4. Look at yellow. Yellow is 4. So the first color is yellow. Second color is blue. Blue is 6. So it's 6. Okay. And third color is what? Is 0. Third color is 0. The fourth color will be the multiplier. Multiplier, which means the number of zeros. Number of zeros is orange. Orange is 3. Then you add 3 zeros. 1, 2, 3. So actually, it's 460 K, 460 kilo ohm. Okay? Plus or minus the tolerance. The tolerance here is what here? This is the orange, which is or orange. This is plus or minus 1%. 1%. Okay. So orange in error is 1%, as explained here in this figure. Let us look at the third one. Third one, this one here. The first color is red, so it's 2. Red is 2. Second is purple or magenta, that's 7, so 7. Third color is blue, which is 6. Okay, and then fourth color is what? Is 0, number of zeros, so multiplier. So it is exactly the same like the 5-band color. Okay, so the fourth color is a multiplier. This means that you don't have any zeros. 0, black is 0, and then this means that you don't have any zeros. So it's just 276 ohm. And here, this is the error. Here, the error is gold. Then it is plus or minus 5%. But it has this sixth color, which is this orange here, and this orange is called temperature, the temperature coefficient. So in the 6-band color, you just have this temperature coefficient. That's it. So there's there's no big difference between 5 and 6. The the colors are 3 digits, and then the fourth one is a multiplier. Then the fifth will be the tolerance. For the 4-band, you have the first color is the first 2 colors are the first 2 numbers, 1, 2, and the third one is the number of zeros or multiplier. Then if we want to apply this here, for example, if you look at this, what is this number here? The number here is brown. Brown means 1, according to the table. Black is 0. And this one is 4. The yellow is 4. Okay, so how can we translate these 2 numbers? Okay, so it will be 1, 0, and 4 zeros. 1, 0, and 4 zeros. And the gold is 5%. The gold is 5%. That will be 1, 0, and 4 zeros. And this means that this is 100,000 or 100 kilo ohm plus or minus 5%. This is the resistance. If we have 6 color or 5 colors like this one is orange. The orange is 3. Second color is 3, orange. White is 9, and orange is 6. Okay, and this one here is brown. This is brown, not orange. This is 1%. Okay, so now if we want to translate these numbers to resistance, okay, then the first number is 0, second number is 0, third number is 9, and this 6 is 6 zeros. That will be 339, 339. So plus, or we add it 6 zeros, which mean mega ohm. 1 million, so it will be 339 million or mega ohm, and plus or minus 1%. To measure the resistance, you have to use multimeter. As I said before, you can use this multimeter, or you can use any multimeter you buy from anywhere. You have to connect this to the right place. It's supposed to be, this arrow is not accurate here. It's supposed to be here. Same for this one is right. Okay, so you need to move it to the ohm to read resistance. So I need to move this here. Now it's ready to measure resistance. Ready to measure resistance. And then we need to make sure that we have the probes right. So for example, this is a common, and we try to find the other place for the probe that has ohm, which is the second one, this one here. Then we need to connect the red to this one here. Then now if we want to measure resistance, we connect the resistance between or to this one here. So now let us see if I want to connect or measure, for example, this resistor, which is according to this, I believe this is a 100 kilo ohm, because it is brown. 0 brown is 1, 0 black is 0, and this one is 4 zeros. So it will be 100K. So what you need to do, just connect it, connect the resistance, connect these two terminals to the resistor. Okay, so now let's go to next slide. Next slide is the exercise. First, we need to find the total, or the resistors in this table. Okay, and then try to measure them. So for example, if you look at 2.2, what's 2.2? Is 2, 2, 0, 0. Right? This is a 2.2 kilo ohm. 6.8, 6, 8, 0, 0. And this one is 1, 0, 0, 0. And 10K is 10, 0, 0, 0. And 4.7 is 4, 7, and 2 zeros. Okay. And now you need to write the numbers, so find the colors. So the colors are, for example, the first one, 2.2, the first color is red, second color is red, or let's just make it in bright colors. Okay, so the first color is red, second color is red, okay, and third color is what? Number of zeros, 2 zeros, then it will be red also. And then second one, 6, 8, 0, 0. So first color is 6, 6 is blue, so it is blue, and 8 is gray, 8 is gray. If we're gonna go back to this one here, see 8 is gray. So let's go to this one. So gray, I hope that I can find the gray. There's no gray. But anyway, let's try gray here. And the third color is red. Red. Okay. Next one is 1 kilo ohm, so it is black. The first color is brown, so let's write brown. I don't see black here. Brown here. Brown. And second color is 0, which is black. Third color is red. And then third one, next one, and so on, and so on. So here this is brown, black, and number of zeros 3. 3 is orange, and so on. Then what you need to do is to find the tolerance. To find the tolerance, of course, you cannot find it from these values here. You have to find the resistor. For example, if you look at the 2.2 kilo ohm, the 2.2 kilo ohm, for example. So I believe this number, this color is gold. So I don't know if you can see this, but I hope that you can see it. Okay. So this is red, 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 and you will find that the fourth color is gold, and gold is 10%. I'm not very good in color, so I'm sorry. Maybe it is silver. Not sure. Seems gold to me. It's gold, so it's 10%. Okay, and so on. For 6.8, I hope that and 6.8 is gold also, so it's 10%, and so on. Then what we need to do now is to measure the resistance. Measure this resistance. So, for example, if I want to measure the 10.10, you can just connect them. You can connect it to the resistance like this, and look at the reading. Look at the reading. Since I cannot do that with only 2 hands, and let me connect them. And the other one also. And now I connected the resistor to the 2 terminals of the multimeter. It's supposed to be 6.8. And now let us see the reading. 6.8. I don't know if it is mirrored, I believe. So let me check here if I can flip this. Okay, so let's see here. So now here it is. Oh, come on. Oh, cannot see it all. And so anyway, this is supposed to be the reading. The reading is 6.8 kilo ohm. Okay, so it is perfect. The value is perfect, 6.8. So now what you need to do is to go and calculate the error. The percentage error equal this value here. So R measured is 6.8 kilo ohm, and the R by colors is 6.8 also. and you divide it by R colors, which is 6.8, and then multiply by 100%. According to this, the error is 0. The error is 0. If I replace this one with the other one, like 2.2, for example, and look at the resistance, it's 2.149. 2.149. So this is not very perfect. So the value is 2.1, almost 5. Okay. And there is a difference here. So now if I want to calculate the error, then the error will be what will be R measured, which is 2.15 minus R color, which is supposed to be 2.2, and divide this by 2.2, then multiply this by 100%. Then the error is negative 2.27%. Okay. Of course, this is okay because the error is 10%. The tolerance for this resistor is 10%. Of course, positive and negative 10%. Then 2.27 is acceptable. If it is more than 10 or less than negative 10, then this is not acceptable. Then what's next? We need to have these resistors, like for example 7.8, like 5K, like 2.78, for example. How do I do this? These resistors. To do these resistors, they are not here in this list. Then you have to make them up. You have to make them up. So for example, how can I do this? How can I do it? You have to connect 2 or more resistors in parallel or series. So for example, 7.8, we have 6.8. If you look at the list or the components you have here in this box, you have 6.8 is available. So if I have 6.8 kilo ohm, okay, if I connect it with 1 kilo ohm, then what is the total? The total is 7.8. So now we're done with 7.8 kilo ohm. If I need to make 5K, for example, what's 5K? Try to look at something in series. For example, we have the resistors that we have 1 kilo ohm, we have 1.5, we have 2.2, we have 4.7, we have 6.8, we have 10, and I believe after that we have 20 kilo ohm, and so on. Okay, how can we make up 5? Then you have to think about a combination between 2 or more resistors to make this 5. For example, you can make 2 resistors in parallel, like for example, if we have 10 and 10, 10K and 10K, and you connect them in parallel, then actually the total will be 10 divided by 2, which is 5K. What about, for example, 2.78? 2.78. So in this case, you have to think about number of resistors that you need to have them in parallel or series that will give you 2.78. Okay. Like for example, if it is 2.2 parallel with some, for example, like 4.7 parallel with 6.8, for example, and try to think about this. Assume that I have 4.7, see parallel with 6.8, 4.7 multiplied by 6.8. Okay, so this is a multiplication over the summation because they are in parallel, equal, and divided by 4.7 plus 6.8. So this is just a try and see. It is 2.78, almost 7.8, 2.78. So how can you make this 2.78 by having 6.8 and 4.7 in parallel? Okay, so this is the total. This is the 2.78 resistor. Okay. What about, for example, here? How do you? Okay, yeah. So this is the answer of this. Second, here repeat for 10.5K. We need to do it, but using two different ways. Two different ways. How can we make them? So you have to think about how can we combine multiple resistors to give you 10.K. We have 10K. You have 10K. Then in this case, if we have, for example, 0.5, how can I make 0.5? Okay, with these resistors. Think about it and try to connect them. And maybe you need to do it in a different way to find this 2.5, because we need to do it using two different ways. And you draw both of them, and after that you do the measurement. You connect them and do the measurement and make sure that it is 10.5. Thank you very much for watching, and see you in the next experiment.